Hello my dear students, good afternoon. Now let's continue the class with classification of elements based on their properties. The first we discussed about representative elements, and then transition elements we discussed. And last few minutes we have discussed about inner transition elements. Who are inner transition elements? Means F block elements. These F block elements are called F block elements. Which block elements are? F block elements are called inner transition elements. Okay. So F block elements means both lanthanides and actinides both will come. So actinides both will come as inner transition elements. So why these are called inner transition elements means these coming in between transition elements, means between lanthanum and hafnium. You are having this lanthanoids which are called cerium 2Lu, lutetium, and actinides is coming between actinium to rutherfordium. So between that actinides what you have here, Mr. thorium 2 Lawrencium you have. Thorium to Lawrencium. They are actinoids. So these are coming in middle of in middle of transition elements. So in between transition elements you are having these lanthanides and actinoids. So they are called inner transition elements. So inner transition elements are nothing but F block elements. So their configuration is very clear. And most of these inner transition elements are these are man-made elements and radioactive elements. Getting what I'm saying? So radioactive elements, why we call them? So they release energy continuously. So their lifespan is very less. So highly active. These also F block elements or these inner transition elements also highly active. Okay. So these general electronic configuration I was given, general electronic configuration of F block or inner transition elements both are same. That means what is that? Ns2, n minus 1, d 0 to 1, n minus 2, f 1 to 14, 1 to 14. So Ns2, n minus 1, d 0 to 1, this is general electronic configuration of Mr. F block. Ns2, n minus 1, d 0 to 1, n minus 2, f 1 to 14 is the general electronic configuration of inner transition elements. Okay. So inner transition elements, these are also completely metals and radioactive as I said. So these are radioactive metals, and these also exhibit only two oxidation states. One is +2 and one is +3. Don't worry, we have oxidation states as one topic, one chapter only we have. No need to worry about oxidation states. Okay, redox reactions chapter only there. So there again we will discuss all these things. So why these exhibits +2 and +3, everything we will discuss. And one more thing, in periodic properties itself, oxidation state is one of the periodic property. So there also we will discuss about the oxidation states of inner transition elements. So just now I am giving you just small information about these oxidation states, but elaborately we will discuss about these oxidation states in redox reactions chapter. Okay. Next one is noble gases, last and final. Noble gases. Who are the noble gases? Noble gases are helium, neon, argon, krypton, xenon and radon. And if you want, anon, octium. These are called, these are noble gases. Okay, except this helium. Helium, as I told you, this is belongs to S block element because it has a duplet configuration. That's it. It has 1s2 configuration. Who is having 1s2 configuration? This noble gas has 1s2 configuration. And except these all have general electronic configuration as octet. What is octet here? 8 electrons in the outermost shell. Ns2, Np6 they have. So noble gases are highly stable because they are having stable electronic configuration, completely filled S and P subshells you have, except this helium. This helium configuration, what we called, I told you, this is only called duplet configuration. What configuration this is called? Duplet configuration. Neon, argon, krypton, xenon, radon and anunoctium means 118. These all having what? Highly stable octet configuration. Highly stable octet configuration. So what is octet configuration? Ns2 Np6. Okay, so here about radon is a radioactive and highly means heavy gas. These all are gases, but this is heavy gas. Okay, now this is a 118 element is recently discovered. If it is completely discovered, this will be a heaviest gas. Otherwise, heaviest gas is radon. Even it is radioactive. Okay, so 118 if completely discovered, it was, if suppose it was confirmed, then 118 will be heaviest gas. So these all are very important. So our classification based on properties four. First one representative elements, second one is transition elements, and third one is inner transition elements, and fourth one is about noble gases. Noble gases, they won't react actually. They are highly stable because they don't have any unpaired electrons. So why atoms are undergoing chemical reactions? To get stability. To get what? Stability. These are already stable. Then why they have to undergo chemical reactions? Okay. So they won't undergo any chemical reactions. These are chemically inert, we called. Inert means unreactive. Okay. Highly stable elements, all these things. And these noble gases are monoatomic. In previous also I was given these noble gases are monoatomic. Do you know what is the meaning of monoatomic? They exist as single elemental state. Helium only, not He2. Neon, Ne, that's it. Not Ne2, not Ne3. Just simply they exist as a single monoatomic manner. So helium, neon, argon, krypton, xenon, radon, like that. They exist. Okay. However, as going down, this krypton and xenon have compounds. As going down, they react. But at a high temperature and high pressure, there only this krypton and xenon will react, because as going down their size increase. Okay, so they have less electronegativity. In periodic properties we will discuss all those things. So electronegativity will decrease as going down, and atomic radius will increase. Their size increase. Certainly they can react for some extent, but not at normal conditions. At high temperature and high pressure, xenon have a compounds, like krypton has compounds. Xenon compounds also, only xenon with fluorine, xenon with oxygen mostly you have. Okay, like XeF2, XeF6, XeO4, like that you have. These also you have noble gases chapter you have in 12th standard. No need to worry about all these things. XeF6, XeO3, XeO4, like this you have compounds. Getting what I am saying? So these all are very important for us. So krypton and xenon can have compounds, but not at ordinary conditions. At high temperature and pressure you have compounds. So these are about what classification of elements based on their properties. Now let's see what are periodic properties. So half of the chapter about classification only you have. Now we have to discuss about Mr. What's that? Periodic properties. What are periodic properties? Let's see now. So periodic properties are what? Why we have to learn means to understand their nature and chemical reactivity. Everything we must understand periodic properties. About nature of that particular element we can understand from the periodic properties. Okay, so here we have to discuss about the periodic property. What exactly periodic property? Periodic property means, listen carefully, periodic property means the property which repeats for every regular intervals are called periodic properties. The properties which repeats for every regular intervals are called periodic properties. Okay, certain properties will repeat for every regular intervals. So what regular intervals means? After every 2 elements, 8 elements, 8 elements, 18 elements, 18 elements, 32 elements. These are the repetition. You remember or not? Periods are 7 and first period consists of 2 elements, second and third consist of 8 elements, and fourth and fifth consist of 18 elements, sixth and seventh consist of 32 elements. So these are what we call the particular regular intervals in periodic table. Why these called regular intervals, sir? Because these are the number of elements present in what? Periodic table, in each period. Okay, in periodic table every period consists of every means each period consists of these many elements like this, in a regular manner like this. First, top to bottom, if you see, the first period consists of 2 elements, and the next two consist of 8 elements, next two consist of 18 elements, and next two consist of 32 elements. Shortest to longest like that, and this 32 7th period is incomplete, I told you. So here hydrogen, if you exclude, hydrogen is a non-metal. Hydrogen has a similar properties with alkali metals, I told you. But hydrogen is exceptional because it is diatomic gas, I told you. So hydrogen is exceptional. So hydrogen also have similar properties with lithium, not a problem, by losing one electron like that. Understanding? So see here lithium and sodium and potassium and rubidium and cesium, if you see. So here first period 2 elements. Here what you have 8 elements, francium. So here 8 elements, here 18 elements, potassium. Potassium means here in this particular period, fourth period, 18 elements, 32 elements you have. See, after hydrogen, after 2 elements the property repeated. After 8 elements, property repeated. Because the elements which are present in the same group has same electronic configuration. Means same number of electrons in valency shell. So that's why they have similar properties. So for every regular intervals the properties are repeating here. So here hydrogen configuration, if you see, it is 1s1, and lithium 1s2, 2s1 here, sodium 3s1 here. Otherwise for few elements I write 1s2 and 2s2, 2p6 and 3s1. In that way 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 here, and rubidium here 5s1 will come. Here 6s1 will come because it will be lengthy, that's why I am writing like this. And francium 7s1. So this all having valency shell. Valency shell means outermost shell which have a highest n value. Here only one, so 1. So here two n values are there. One is 1 and here 2. So this is valency shell. Here 1 you have and 2 you have, here 3 you have. So here valency shell. Here 4s1 is the valency shell. Here 5s1, 6s1, 7s1. See, if you observe, these all have configuration commonly ns1 for alkali metals except hydrogen. Hydrogen is not alkali metal but belongs to same group, 1A group. So these all have similar properties now. That means what I am telling you, for every 2 elements, after 8 elements, after 8 elements, after 18 elements, after 18 elements, and then after 32 elements, here to here, after 32 elements, the property is repeated or not? Why the property is repeated? Because they have same number of valency electrons. So group elements have same properties. Group elements have same properties. Why? What is the reason? Because those group elements have group elements have same valency shell configuration, otherwise same number of valency electrons. So group elements have same properties because group elements have same number of valence electrons. Valence electrons means understood, outermost electrons. Outermost, how to have highest n value. Highest n value means this n value. This is called n value. This 3. Here this is highest n value 4. Because here numbers you have or not. 1, 2, 3, 4. So this is the highest n value, that is 4s1. And here it is 5s1. And comes like that. From beginning 1s2, 2s2, 2s3, blah 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 like that. 5s1 will come finally. So this is about periodic property means what exactly. So I was given what is periodic property. Clearly we have to understand. Time matter is not a problem. We must understand first. What is periodic property? The property which repeats for every regular intervals. Okay? Is called periodic property. Okay? How many periodic properties we have? Means so many we have. One by one we will discuss. First we have to discuss about atomic radius. And the second one is ionization potential. Third one is electronic affinity. And fourth one is electronegativity. Fifth one is about valency. Okay, sixth one, as I told you about oxidation states, we will discuss. I told oxidation states, reducing ability and oxidizing ability, and acidic nature and basic nature. Like that we have periodic properties. One by one we will discuss. No need to discuss like all at one place, first writing and then one by one. No need. So first let's go for atomic radius. What is a radius? Atoms are assuming as a spherical manner, because in atom who are present? Orbitals are present. Orbitals are what? Spherical manner. So atoms we have to consider as spherical manner. Spherical manner. So if you consider spherical manner, only if atom exists in a single monoatomic, then for spherical, if you are assuming like this, here to here half of the distance from nucleus to outermost shell, this is called atomic radius, we can say. I'm talking about what? I'm talking about atomic radius. I'm talking about what, sir? Atomic radius. If atoms are isolated means what? Singly atoms if exist, they don't have any other interactions, suppose. Okay, no other interactions with any other elements, then you can say the distance from nucleus to outermost shell is called atomic radius. If atom is isolated means what? There is no attractions with any other atoms. Only atom exists in single. Okay, one atom exists in a single manner, means no relation with any other elements, no any other atoms. Then what you can call? Half of the internuclear distance. Half of the distance, or the distance from nucleus to outermost shell, is called atomic radius. If atom is isolated, what you can say? If atom is isolated means what? No link with others, single. If atom is isolated, then the distance from nucleus to outermost shell. For sodium, suppose, nucleus to third shell, because who is the outermost for sodium? Sodium, if you see, 1s2, 2s2, 2p6, 3s1, means what shell? This is K shell, I told you. You remember? This is called L shell, I told you. This is called M shell. So for sodium, what is radius? If atom is isolated, I am telling you, condition is that So the distance from nucleus to outermost shell. Suppose this is K shell and this is L shell and this is M shell, because K shell consists of 1s, L shell consists of 2s and 2p. I told you K, L and M. So distance from nucleus to outermost shell, because outermost shell means what I told you, highest n value. So this is called now radius for sodium. You can say like this, but no atom is isolated. Understanding? Atoms are in combined state. Atoms are in combined state. Even noble gases, one noble gas atom with other noble gas atom, they have weak interactions which we call van der Waals forces. Remember this word what I use now. Between noble gases atoms, there is a weak forces. Between gases exist those weak forces. Remember this. Between gases, atoms or molecules, some weak forces was identified by one scientist, Van der Waals called him. Van der Waals, scientist name. He was given between gases, atoms or molecules, some Van der Waals forces exist. So, no atom is isolated. So, atoms are in certain bond. Atoms are in certain chemical bond, because all atoms are not stable. Even noble gases are highly stable. Between two gaseous atoms, there is a weak interactions. Why, sir? Means nucleus of one atom, electrons of other atom have some kind of weak attractions. Those only we call van der Waals forces. I repeat, what is van der Waals forces? The nucleus of one gas atom, electrons of other gas atom has weak forces. Those are called van der Waals forces. So, no atom is isolated. Atoms are in certain chemical bond. So, based on chemical bond, the particular atomic radius classified as 4. Classified as what, sir? 4 kind. First one we have to understand. First one is covalent radius. What radius it is? Covalent radius. So where you will have this covalent radius? Covalent radius we will have in covalent molecules. How covalent bond will form? Sharing of electrons, contribution of electrons and sharing of electrons. That we will understand in chemical bonding chapter. So if atoms are in covalent bond, of course in 10th standard also you have some idea about this covalent bond. Two atoms will contribute electrons and they will share that electron pair. They are called covalent molecules. Covalent, that bond is called covalent bond. So in covalent molecules, we will consider radius as covalent radius. Getting what I am saying? So if two atoms are in covalent bond, then the covalent bond representation is like this, sir. This is one and this is another atom. Okay, suppose here hydrogen you have with one electron and another hydrogen is there like this. So this is one and this is another hydrogen. So hydrogen and hydrogen will have some conversation. So this hydrogen is saying that I have one electron. Please, I want one more electron. Then this hydrogen will say, yes, I need one electron like you. So we will combine and we will share this electron pair. This is contributing one electron. This is also contributing one electron and forming electron pair and sharing that electron pair. So what you have here is single bond H. So this bond is what? Covalent bond. Who will form covalent bonds? Non-metals. I was given now. So non-metals are forming covalent bonds. Metals forming metallic bonds. Gases having what? Van der Waals forces. Between metal and non-metal, ionic bond. So two non-metals forming covalent bond. Two non-metals forming covalent bond. So in non-metal molecules, we will consider covalent radius. Between two metals, metallic radius we will consider. Between metal and non-metal, ionic bond will be there, no? So ionic radius we will consider. So where we will have ionic radius? Between metal and non-metal if forming a bond. What we call NaCl example, Na plus Cl minus, forming ionic bond. One losing electron and one gaining electron. Sodium lost electron, chlorine gained electron. Understanding? Between two gases, we will have van der Waals radius. So here what is covalent radius? Means this is one and this is another. So here to here is called internuclear distance. What this distance is called? This nucleus to this nucleus is called internuclear distance, here to here. This is called D. What is D means? Internuclear distance, which is also called bond distance. Then what is radius? Radius is D by 2. What is radius? D by 2. So what is covalent radius? Now you can say half of the internuclear distance, means from here to here. So exactly half of the internuclear. What is internuclear distance? Understood? The distance between two nucleus of two atoms which are covalently bonded or which are in metallic bonded or which are in ionic bonded. That is two atoms when they are in closest approach. Closest, that will be the maximum approach. Means they cannot come closer than that. Okay, so they approach like this. Then the distance between two nucleus is called, what that is called? Internuclear distance. That is also called bond distance or bond length we call. So the internuclear distance is nothing but what? The distance between two atoms of a nucleus which are in closest approach. Okay, half of the internuclear distance is called, this distance is called, what this is called? Radius. What this radius now? This radius only called covalent radius. Covalent radius. So what is covalent radius? Tell me now. The distance between two nucleus of two atoms when they are in closest approach is called bond distance or internuclear distance. So the half of the internuclear distance between two atoms, half of the internuclear distance between two atoms when they are in covalent bond is called covalent radius. So I repeat, this covalent radius, okay, if two atoms are in covalently bonded, then half of the internuclear distance between two atoms is called covalent radius. Getting? Suppose Cl and Cl bond. So chlorine and chlorine both are non-metals. So they are in what bond I told you? Covalent bond. Between two non-metals, covalent bond. So one chlorine is like this, another chlorine is like this. So between these two internuclear distance is that. Okay. So internuclear distance half means here to here. What this is called? Radius. What radius this is called? Covalent radius. So if D is X, X angstrom like that, then what is radius for chlorine? X by 2 angstrom. Units for radius is the small units of length we will use. Okay, those are what I'll tell you now. First, atomic radius means what? If atom is isolated, I told you, half of the distance from here to here. So distance from nucleus to outermost shell is called atomic radius if atom is isolated. But no atom is in isolated state. Of course, noble gases are isolated. But noble gases also has weak van der Waals forces, I told you. But few remaining are having some covalent bond or ionic bond or some metallic bond like that. So based on the chemical bond, we will classify the radius as covalent radius, metallic radius, Ionic radius, van der Waals radius. We discussed about a covalent radius. So if two atoms are in covalent bond, half of the internuclear distance is called covalent radius. So covalent radius for chlorine is just from half of the internuclear, from nucleus to half distance here. So if the internuclear distance is x, then radius is x by 2. Okay. Now what is the units? Units of radius. Units of radius is small units per length. Angstrom, nanometer, picometer, micrometer, like that. These are the units for radius. Usually they give angstrom, nanometer, picometer, like that. Do you know 1 angstrom is how much? 1 angstrom is equals to 10 power minus 8 centimeter or 10 power minus 10 meters. 1 nanometer is equals to 10 power minus 7 centimeter or 10 power minus 9 meters. This is 1 nanometer. Do you know 1 picometer? 1 picometer is 10 power minus 10 centimeter or else 10 power minus 12 meters. Okay, 1 meter is equals to 10 power square, but here inverse. Okay, 10 power minus 8 centimeter and 10 power minus 10, getting centimeter. So 1 centimeter is equals to 10 power minus 2 meters. So 10 power minus 8 centimeter into 10 power minus 2. So 10 power minus 10 meters. Don't get confused. 10 power minus 8 centimeter or 10 power minus 10 meters. Units of radius here we discussed. So what we discussed? Covalent radius. In covalent bond, one more important thing, one atom into other, like this. Not like this. Not adjacent. One atom into other in covalent bonding. Because they are strongly bonded. Like this. If like this is just metallic bond. Like this. This is, see, one into other. My left hand is some portion you are unable to see. This is called covalent bond. Means one atom into other. Okay. So next we have to discuss about the metallic radius. So what is covalent radius? We have idea now. Half of the internuclear distance between two atoms which are in covalently bonded is called covalent radius. Now let's see metallic radius. Very simple. Between two metals. Between two metals, the radius, what radius exists? Metallic radius. Between two metals, metallic radius exists. Metallic radius exists between whom? Between two metals. Metallic radius is just same thing, the half of the internuclear distance between two metals which are adjacent to each other. Adjacent to each other is called metallic radius. What is metallic radius? So between two metals, actually metals are solids, like this they exist. Not one into other, just one beside to other, like that. Get it? So I'll write like this. Metals how exist? See, like this exist metals. Metals are closely packed. Okay. So metals won't exist like this. This is wrong. Metals exist in just one adjacent to other. So between two metals, what interactions you will have? Same, nucleus of one atom, electrons of this. So between these two, there is an interaction. Nucleus of this atom, electrons of this atom, metal atom, have small interaction. That is called metallic bond. So when two metals are adjacent like this, so here again half of the internuclear distance. This is called D. But this is called D. And here to here, what we call? Here to here, this we call radius. Getting? So what is metallic radius? Very simple. Half of the internuclear distance. Nucleus means you have idea. In center of atom is called nucleus. Okay. So between two nucleus, the distance is called internuclear distance. Half of the internuclear distance is called radius. Okay. But between two metals here, getting? So there also covalent radius same and half of the internuclear distance. Here also half of the internuclear distance. But what is the difference? There half of the internuclear distance between two covalently bonded atoms. But here two atoms which are metals. Between those two metals, half of the internuclear distance we consider as metallic radius. Getting? So metallic radius and covalent radius difference. This is. Now let's see. Between whom you have covalent radius? Between here this atom to this atom. Here what radius? Covalent radius exists. Why covalent radius exists? Because this one and this one are in covalently bonded because one atom into other. So here the radius is R. But whereas here metallic radius here. This is R. Suppose this is R1, this is R2. This is what radius I told you? Metallic. How I am saying metallic? Because metal atoms won't combine, won't share electrons. Metallic bond is simple attraction between nucleus of one metal, electrons of other metal. So metallic radius is R2 and covalent radius is R1 if I am considering. Which is big? Covalent radius bigger, metallic radius bigger. Metallic radius is always greater than covalent radius. Why? In covalent molecules, one atom into other means closest approach where you have in covalent bonds we have. So these are very nearer. That's why radius will be less. So among covalent radius and metallic radius is always greater. Understanding what I am saying? Sure? Okay. So metallic radius is always greater than covalent radius. But metallic radius is big or covalent radius is big, they'll ask you for certain elements. Metallic radius is always greater than covalent radius because in metallic bonds the approach is not very close, but whereas in covalent molecules the approach is very close. See, here distance is more or here distance is more? Here distance is more. Certainly half of the internuclear distance will be more. So metallic radius will be more than covalent radius. Thank you. And tomorrow we will also discuss about remaining two types of radius. One is ionic radius as well as van der Waals radius. Thank you.